Hi, this is Mike Lavelle. In this presentation, I'd like to talk to you about how we can combine the power of Google Earth and Building Information Modeling, or BIM, to better understand what's going on inside a building, to navigate in and around the building. This particular building is the iPower Energy Building in Anderson, Indiana. And here we have the building in 3D that was built in BIM. And you can see I have a number of place marks in here. The place marks are kind of interesting. When I first got to the building, I walked through it, and so I put a place mark here to bring up a video that talks a bit about what the interior of the plant looks like. Let's have a quick view of what that looks like. So we're walking through the building. You can see the test cells in the background. And we have all these extraneous videos too. So as we're looking at it, test cell number 1 is where we have the generator for the Army project we've been working on. Gives you a little perspective of what's going on inside the building. And I climbed the tower, or to the roof, and I was able to get a better view of what the roof looks like and how the units are installed on the building. The game plan here is to get the technical details. In this particular video, I did a quick once across the top to see what was going on. So we can get the technical details from that, and then I went downstairs and I looked inside the building. I was particularly interested in how the utility services were coming into the building. So I went to the electrical distribution room, and here I got a quick understanding of the metering and the electrical gear.
Meters. There are actually 2 meters here. One meter is for EMPA, and the other meter is for the Anderson Light and Power. They have an arrangement where they can feed power back to the network.
So it's kind of an interesting situation because iPower participates in the generating of electricity as well as the consuming of it. They're working closely with the local utilities to take care of that. It's also interesting to note that it wasn't necessary, or it isn't necessary, for the utility to send someone out to read meters. They have effectively remote dial-up.
Electrical service is monitored by a dial-up network. We have a telephone line coming in. It's 608-1086. And we have 2 lines coming out of this device. It's called a Hello Direct Auto Switch Pro phone line management unit. So the 2 wires are coming out. One goes to each of the meters. So they have remote monitoring of the power on each one of those. No need to send someone out to check the current energy usage.
And that's a very good way of handling it too. So as I navigated around the building, I was looking at various pieces of equipment, and one of them was the building automation system. Here was the Honeywell Tritium unit that was installed. It is installed to manage the utility or the energy usage
This unit also includes
for the rooftops.
Communications. That's wired to and connected with the Honeywell Tritium unit.
Kind of get an idea what that's about. And in the process, I've captured a number of items of a piece of equipment so that it would be possible to have a record of what was going on. Let's look a little more carefully. Here is an object. This is a picture of the Linux unit that I took off the Linux website. The most interesting part about this, though, is that I'm able to provide some real-time information from the high-power test cell. This is an image of what we've captured in the past from the generators themselves. This data actually comes out in real time. You can see the voltage, the amps, the frequencies all change as the generator and its small microgrid is running. And the point here is that it's possible to view real-time information over the internet through Google Earth or Google Maps, either one, so that you can see the real-time data as it's actually running inside the building. You have the additional advantage of a perspective, i.e. you can literally walk through the building, if you will, or drive through the building. You can find some real-time objects, you can click on them, and you can get the technical details by looking at a video, or you can pull out from some distance and take a look at some of the smaller or the more interesting things. And again, this is the high power energy information. The way we made it then was to take a look at and use the OPS, the Onuma planning system. Here we're able to superimpose on top of a video capture, or capture from Google Earth, the location, and I was able to draw the building physically, just moving the lines, and I was able to match it up that way. And then I noted that the building had a couple of floors, so we'll show the floors coming up here. This is floor number 1, and in that floor we're able to take advantage of the ability to zoom and navigate, and so the corner office is sitting over here, and I can pull up that corner office, as you'll see here in more detail. In comes the information. This particular office has a couple of cubes, and this represents a diffuser. So we're able to add good content, meaningful content, and link it all back to the Google site that shows what's going on. Then by taking advantage of the VROC technology, we can link physically the devices inside the building to real-time data via the web. This is all coming off of our Amazon EC2 server. That's the highlights of it. I'm glad you had a chance to take a look at it, and more to come.